So hi guys. So magso-solve tayo ng alternator problems. Open circuit test, short circuit test. No. So 500 kilovolts ampere, 2300 volt three-phase alternator is tested and has a short circuit current of 204 amperes at an open circuit voltage of 2300 volts. The average DC resistance of the three armature winding faces between pairs of terminals RT is 0.8 ohm. Calculate the value of ZS and XS. Assume the effective AC resistance is 1.5 times the DC resistance. Calculate the percent regulation of full load power factor of 0.8 lagging. So meaning ZS guys is a synchronous impedance and synchronous resistance. So first guys, no. So let's try to given of course. So sorry, given so given so we have of course we have S or apparent power 500 kVA, right? We have that one kVA. And now it also says that we have short circuit current of 204. And let's try that. I S IC meaning short circuit current 204, right? 204 and 204 ampere, and of those course we have open circuit voltage, so ESC, and kuan siya 2300 volts, and terminal, so we have a RT, no, RT na 0.8 ohms. Okay, so now it says that calculate the synchronous impedance and synchronous reactance. So first is, no, we have this formula, no. So we have this formula solution. Let's write this solution. So make this solution. Dako yun siya, pero sige ra. Solution. Alright, solution. Now we have this formula of synchronous impedance. So let's say ZS is equal to ESC, uh, EOC, sorry, it's open circuit pala to, EOC. This could be changed by EOC. So I forgot this. Should be it says an open circuit voltage, so we can change this at EOC, right? So I'm sorry guys, that's a mistake. It's supposedly EOC lang. EOC meaning open circuit. EOC and ISC. This is the formula of synchronous impedance. Now, but the thing is, when we solve the here the three-phase alternator, we assume it is ano, we should assume that it's a three-phase. So meaning this one should be converted in phase, our EOC, right? Open circuit voltage. So we should convert it to phase. So in order to convert that, so we have this EOC, EOC, EOC phase. Let's just put a P here, meaning phase. EOC phase is EOC. We just we just divide it by square root of 3. And we can have, using your calculator, no, 1000 over square root of 3. It's 1327. So 1327.906. Three decimal places lang tayo guys. 906 volts. This could be our phase. And now we have this one. So it should be on phase. So we could do here is simply put the values. No? So 1327. So it's 1327.906. 906. I'm having a hard time to do this. 906 all over the IEC. IEC is 204 ampere. 204 ampere. And we can now have this answer. So in that 1327.906 divided by 204, we will get an impedance of 6, synchronous impedance by 6.509. Okay, and now we should also calculate the synchronous reactance. So we have this reactance, no, XS is equal to the square root of synchronous impedance, yes, synchronous impedance GS squared minus the RA, the armature resistance squared. So of course we have already the impedance, and we have also, if I'm not mistaken, we have the RA here. Alright, so since we have this one, RT, RT is given, but we have no RA. So we can solve for RA. For RA first, let's solve for RA. So here, RA, it says that it says that RT between pairs of terminal RT is 0.8 ohm. Therefore, we can do this RA, have this RA, RT, RA is, alright, we have this formula RA is equal to, this could be the round formula here, round times the R, RD. Okay, But RD, mute, sorry guys, nas muted na rin. RD is equal to RT over 2. So we have an RT na 0.8 in our given, it would be divided by 2. So we can solve for RT. Say 0.8 divide 2. It's 0.4. 0.4. Yes, it's 0.4. And now, since we all had RD, we have the round in our given. It says multiplied by 15. I'm not mistaken, it's 15. 15 times of DC resistance. So that's our round. So can solve the round. So this is equal to round 1.5, I guess 1.5 or 15. I forgot. It's what? 1.5. So it's 1.5. It's 1.5 times the RD, the 0.4. So we can solve for RA. So 1.5 times 0.4, it's 0.6 ohms. This is an ohms. So we can solve for XS, right? So XS, you have all the RA and ZS, asynchronous impedance. So we have this one, 6.509 6.509 minus 0.6. But by the way, this is squared, should be squared, and this also be squared, based in our formula. And now, when solving that, using our calculator, 6.509 squared minus 0.6 squared. So we will get 6.481. Okay. It's also an ohms, okay? This is an ohms, this is also an ohms. So we already solved the synchronous impedance and synchronous reactance in A. Now the B says that calculate the percent regulation of for a full load power factor of 0.8 lagging. Okay. Now first it says lagging. Okay. So here for B, let's say add this for A. For A. For A. Now here for B. For B. For solution for B. Okay. Now, okay. We have we need to we have an PF per factor, the per factor PF, that is 0.8 if I'm not mistaken. 0.8. All right. Yes, 0.8. And we can get this by can this you can use we can get the angle of this by angle by inverse cos of what? 0.8, right? And we can get the inverse cos of 0.8. We can get the angle, which is 36.87. 87. Okay. It's degree, right? Degree. And we can also, it says also the problem says that calculate the percentage of full load power, meaning the full load power. So we have S here, right? We have apparent power. we all know that apparent power is S is equal to um, V, voltage, and I. We can solve for the full load current here. So we have an I, but in terms of, okay, we just first like this. Okay, so it says that uh 500 kVA, 50 kVA, right? I'm not mistaken. Oh no, it's 500. 500 kVA is equivalent 10 to the raised to the power of 3. And voltage, we can get the voltage is 2 2300. But we should always convert this current in phase, no? Full load in phase. So I just changed the sign. This could be a I full load pace in pace, right? IFP. So should have a square root here, 3, and times this 2300. Okay, so we will get, using our calculator, 500 times 10 to the 3 all over square root of 3 times 2300. We will get 125.5111 ampere. Okay, so okay, so yes. Now, to in order, it says that lagging. We all know that we have the formula of this lagging. No, we have this a formula of lagging, that lagging is uh, EP is equal to square root of V pace, V pace, V pace cos theta plus RA, or ERA, or what? ERA, this could be squared plus VP, VP meaning voltage in pace, sin theta, sin theta plus plus EX plus EAR, okay, and squared, meaning EAR, guys, it's armature reaction, and this is a voltage drop of synchronous reactance. Okay, so now to get this, we already have the voltage in pace. We also have the angle, which is we solved already, the 36.87, and EAR, as we can solve this by ano, we have the RA already, so we can solve for that, and also the EX. So yes, uh, so we can do here is, we know that EAR is EAR, ERA is equal to I phase, I full load, no? IFP, or the current full load per phase times the RA. And we can get that by, it says that it's 125, no? 125.511, and RA is, if I'm not mistaken, it's 0.6, I guess. RA, what we solve? RA is 0.6 ohms, so we can get 0.6 here. So we can have 125.511 times 0.6. We'll get 75.37. 75.307. 307. This is a voltage. Okay. So in EX, we can also solve for the EX, no? So EX, same current, I full load per phase times the XE, no? So same, it's 125.511 times, we will get our XE, or XE, XS, sorry, should be XS. We just get the wrong ano. This one is XS. Okay. XS is what? 6.481. No? 6.481. Yeah, 6.4481. And we can have 125.511 times 6.481. So we will have 813 point, this is 813.4437 volts. And here, EAR, or the armature reaction, since in the problem it didn't mention na naay armature reaction, so we should neglect it. All right? So it's considered as zero. So since we already have the the all the given, no? So we can just simply put the values and we can get the EP and then solve for the voltage regulation. So just so EP, so EP is equal to square root, no, VP, if I'm not mistaken, 1327, I guess. So E VP, by the way, VP is equal to EOC base. Okay? So 1327.906. So 1327.906 cos theta, which is 36.87. 36.87. This could be honest, guys. 87 plus the ERA, which is 75.307 7 squared plus, by the way, this could be ani, taas kayo ni guys. VP again, it's 1327. So we have this 1327.906 906 906 sine theta, which is 36.87 plus the kuan the EX, which is 813.47 813.437, and don't forget this is squared. Okay, now when we input this to our calculator, so EP is equal to, when we input this in our calculator, so we have 1327.906 times cosine of 36.87 plus 75.307 squared plus VP 1327.906 times sine of theta of 36.87 plus EX, sorry, 813.437 squared. Then our answer is 1, it's 1971, it's 1971.52 volts. Okay, now we need to find a voltage regulation in this. So we have a, what is the problem? The problem says is full load power factor, percent regulation of full load. So let's say is percent percent reg regulation, so FL meaning full load is equal to EP minus VP over VP times 100. So we can solve that. We already have the EP, which our EP is this one, no? It's 1971 19 1971 1971.52 minus, we have our V pace, which is 1327.906 to 7.906 over VP again. So 1327.906 times 100. Okay, our BP, use our calculator. So 1971 132 minus 1327.906, 1327.906 times 100. So it's 48%, no? So it says percent is 48.468. So this could be our final answer. Okay. So that's it guys. I hope you learned something. So tara, solution.